jobs are depending on each other. We just use it mostly as an execution.
It's only the sponsors listen to me only. And yeah, so the schedule is where there's going to be a talk by Peter about Prezi's a platform framework. Then there's going to be some nice food, pizza, and a second talk by Patrick. So yeah, and I think a fishbowl discussion. So yeah, welcome.
Thanks. Can you hear me? Okay. So, first of all, thanks for the invitation. I'm Peter Csizsek. I work for a software company called Prezi. It's a Hungarian software company, and we provide online presentation tools as a service. For example, this presentation is using that, so you can check it out. And the thing that I want to talk about is that around a little bit more than half a year ago, we built a tool that integrates the elements of our continuous delivery pipeline. So we claim to be an agile company, and we already had our continuous delivery pipeline set up. But the problem was that it just took a very long time to integrate projects into like every part of the continuous delivery pipeline, and we wanted to solve this. So this tool is called Igor, and I'm going to talk about it. So as I told you, the motivation behind it when we decided to work on this project was that it happened on last summer when one of our most experienced software engineers, it took him for 2.5 days after finishing a very basic service to integrate that service into our monitoring infrastructure, creating proper Jenkins job and build jobs for it, and set up deployment scripts and everything. And then we decided to like carve out a small part of the infrastructure engineering department and create a new team from that called the Platform as a Service team. And I'm a part of that team, and we were working on this tool. So then when this happened, we just realized that it's taking too long to build a service. So the whole point of the project was to take down the time requirement for creating a backend service. I'm talking about backend services right now. We have another team for making the front-end developers' life easier. So we wanted to take down those 2 days into basically 3 minutes. So like just a console command you type in and your service is created, assuming that you already have the working code. So why is it required? So, for example, how this presentation and or browser-based presentation tool works is that the user starts up the Prezi tool in her browser, and it connects to the backend service that serves, like, provides you all the images, the videos, and also the presentation XML and everything. But in fact, there is no one backend service, but there are a lot of backend services. And what's more important about them is that we want to have even more, because we want to move the whole backend architecture towards the microservice architecture. I want to talk about this architecture a little bit more. So in the classical setup, you have your client, which might be the desktop tool that I'm using right now, or a browser-based, and it's connecting to one or just a few monolithic backend services. But the architecture we want to achieve in the next 1 or 2 years is that we want to have this microservice architecture when, like, basically there is service discovery within the client tool, and it's just picks based on the type of the request which backend service to connect to. And there are even some services that are not connected directly to the users, but only connected by other backend services. And why is this microservice architecture good? It's for a lot of reasons. First of all, if your backend services are small, they are they are easier to maintain. So like there is only a few hundred lines of code in each, and instead of having to touch a service that has like 2 million lines, it's like you just open up it in your editor, and in 5 minutes you can see the whole thing that is happening in it. It's more reliable because it's harder to fuck up a service that's only just a few hundred lines long. Also, you can introduce gradual changes. So if you have these smaller services, then you don't have to introduce big changes, which completely leads towards the direction when you have continuous delivery, and you are just basically deprecating the APIs through which are these backend services connected to each other. So you just deprecate an API, introduce a new one from one service, and on the other side of the connection, the other service that's using that API, you just upgrade that as well. And like in 2 steps, you can upgrade the whole connection point, and like in the whole process, you don't risk anything because you are not introducing big changes. It's also more robust because if you write them in a good way, then the failure of one backend service doesn't bring the other services with itself. It also enables parallel deployment, development of the services, because like the magic number we figured out is that basically throwing engineers into a project after the 4th one, it's not really increasing efficiency. So if you have many backend services, then you can let your developers work on separate services, and maybe only 4 at a time, and that means that everybody is at maximum effectivity. It also enables you to isolate problems. So when there is an outage, then you can easily find where the problem is, because just one by one you examine all your backend services, and if the connection is broken between them, or you just try to mock some services, then you can easily find where the problem is, and you don't have to debug one monolithic monster service. It also enables you to different tools, so one can be in Python and one can be in Java or whatever you want to use. And you also can use multiple languages, different tools. But it also has a lot of disadvantages. For example, you push complexity from the software architecture, from the monolithic service, into the complexity of the network between these microservices. So basically every call that was just a function call within your code, now that's an actual network call between those services. And network connection is much less reliable than a function call within your call. So you have to deal with these problems. You have to have fallback logic, and also like dynamic service discovery, load balancing, everything. You have to solve these problems. So using different tools, on one hand, it's a very good thing, but if you let your developers use different tools, eventually they will use different tools, and someone thinks that it's a very good idea to implement this greenfield project in Haskell and things like that. So you have to deal with this. And the biggest problem, and the whole point of this presentation, is there is something called the service creation overhead. And by this service creation overhead, I mean everything that's between you having the code on GitHub and you running your code on a production server. So everything that's between them is something that you have to do for every service. And what it exactly means for Prezi, first of all, we have to integrate all our backend services into our testing infrastructure. We use a Jenkins cluster for testing our backend projects, which means that you have to write all the test jobs for your services. If you have these flow jobs that like different test phases triggering each other, you also have to set up these dependencies. And like for every service, you have to write wrapper, shell scripts, or whatever you use for running the actual code test. Another one is building. Is the same thing. Basically, we use Jenkins for building. So the end of the test, if the build artifact passed all the tests, then we just keep it. So it's not a different step, but still you have to do everything for every service. And we use, most of our backend services are on Amazon Cloud. So we have to have a lot of things to set up for every service. We want to keep them isolated and only give those services the permissions that they absolutely need. So we have different security groups, IAM users, user permissions, and different policies for these services. And okay, they are not very complicated, but they still take a few hours if you want to set them up properly. And it's basically, even a monkey could do that after like the second time. So it's like very easily automated, but takes a lot of time if you do it by hand. We use Chef for configuration management. So for every service, we have to have all the cookbooks and the recipes within them and the roles to make the configuration changes on the servers for these services. Also, you have to install all system dependencies, and you have to put there the deployment scripts that actually deploy your service on the production servers. And also deployment. So we have our own built deployment system. And for that, you have to integrate every project into that. So you have to specify the target servers. You have to specify the deployment policies. We have different deployment policies for critical services. We have these canary deployments, which means that first we deploy the new version into one server and examine the traffic for like 2 minutes. And if it looks good, then deploy it to 2 other servers. And if it still looks good, then like gradually roll out for the whole cluster. And if like there is a failure somewhere in the process, just roll back everything in one go. And you don't have to implement this for every which of your services, but you still have a lot of things to set up to make it work properly. And also monitoring. So we use Itzinga for monitoring, and if you want to monitor the services that you've just built, you have to put it in the monitoring API, which means that we can generate Itzinga configurations from those settings. Also, you have to write your own check scripts and the alert conditions, and for example, set up PagerDuty alerts and all that sort of things. So these are all the things that I mean by service creation overhead. So if you want to have a new backend service at Prezi, these are all the things that's between you having the code. Like, please note that these things are like happen after you already implemented the software itself. So these have nothing to do with any business value from the user's perspective. And these are the things that's between you having the code and you running your code on a production server. And this is that takes more than 2 days. And there is one other factor, which is the fun part of software engineering. So most of our engineers, they like the part of writing software when they actually have to write the logic. So everything that's before or after that is just not so fun. Like creating the service means like creating actual directory structure and auxiliary files is just not something you want to do by hand, and you want to do for every single microservice. And also at the end, integrate your project into testing and build. You just don't like it. People like writing actual code. That's what they like. So that's how we came to the conclusion that at our company, creating a backend service is just too complicated, time-consuming, it's error-prone, boring, but more importantly, it can be automated. So all these steps can be automated by a bunch of Python scripts. So we were thinking about maybe somehow pushing all these things together and building a tool from this that could be the solution for this pain. And this is how this decent person comes into the picture. Does anybody know him?
Igor.
Yeah, it's Igor from Frankenstein movie. So basically he's the helper of Frankenstein. He does all the boring stuff for Frankenstein so he can work on his evil world domination plans. So we wanted to do a tool for all software engineers who do the boring stuff for them. And this is our Igor. So the goal was to make it fast, easy, straightforward, and more importantly, fun to create a backend service so software engineers can actually concentrate on the business value they generate. And we had some KPIs for the whole project. It was a very new team, so we needed very strong guidelines to not to fuck up or basically not to work on something useless for half a year. So we choose 3 key performance indicators. One is speed, and robustness and penetration of the tool. For speed, we wanted to take it down to 3 minutes to create a backend service, so 3 minutes of manual work. We also had another number like the other 57 minutes, so 1 hour altogether. It can be machine time, so like processing and background jobs and everything, but it would need only 3 minutes from a human. It has to be robust, which means that like only one user interaction is needed with the tool to create a new service, not just checking like every 5 minutes if it finished and I can execute the next command or something like that. And also penetration, so we wanted to have 80% of the new backend services that were created after releasing the first version of this tool. We wanted to have 80% of those services to use the tool. So we didn't want to work on something that our developers don't use. Like 80% is fine because there will be always someone who doesn't want to use your tool because he thinks he's more clever or you are not like serving his needs, but 80% is fine enough. So the development methods we used, we were very like intentional about how we developed the whole project. So we had very clear goals and we had strict measures. So we were contacting our users and we have every week, and we also had our dashboards for this. So we try to measure every single thing we are doing during this process. We also had a persona. So we borrowed this idea from the project managers that when they develop a new feature, they always like make up a persona who would use this feature. So our persona during this development process was a 21-year-old girl who just came out from university, and she gets hired by Prezi, and she has her first task setting up a new Python service that has to return hello world in a JSON response. So we used her as a persona, like this tool should do everything that she doesn't want or can't do with these tools. We also used iterative development, which means that unfortunately this team is responsible for a lot of other things, so we didn't have all our time to spend on developing this tool. So we did it in 4 or 5 one-week-long sprints. So and then we could reflect to what we were developing, and we had some time to actually examine the thing that we were doing and try it. We also try to do feedback-driven development, which means that we were contacting regularly our own users and ask them what they like and what they don't like about the tool. And we also use dog fooding, which means that we ate our own food, because during the development of this thing, we also had to set up new services ourselves, and we tried to use the prototype of the tool setting up those services, and we knew exactly what was wrong with it or in what way was it inconvenient to use. So this is how it works. It's a command line tool. Basically, it's installed on the developer's computer, and the different modules of the tool, they connect to our different systems within the company. So these are the some parts of the continuous delivery pipeline, and basically when you enter commands to it, it just goes to the appropriate module, and that contacts the appropriate part of our infrastructure. Most of them are wrapped by some APIs, and yeah, basically you just communicate with those services, what you would do otherwise from a GUI, and like click yourself security group on AWS, or just put it into our deployment system or whatever. It also included that some of our systems didn't have a nice API, and to be able to create this tool, we had to first transform them in a way that they can be managed by an API. So this Igor tool, it's written in Python, and it's a command line tool. There you can see some of our favorite Python libraries, and in the middle you can see this Igor YAML file. For those who are not familiar with this YAML file format, it's basically JSON without the curly brackets. So it has the same data types, the map, the list, and the primitive data types are strings and numbers. So it's pretty much the same thing as JSON, it just has a different syntax, and we thought it's more readable by humans, and it's easier to read and write than JSON, but it can be one-on-one transformed to JSON. It's literally 2 lines in Python. So we used this YAML file format, and in this file, you basically write everything that describes your project. So, for example, there is a part, this is the build part, and I think everything explains itself. So you can build my project by testing the return code of that shell script that's in the first run command. And we are talking about Jenkins jobs, so it has a triggered attribute, which means that is it triggered by another Jenkins job, or is it the root Jenkins job of the project, which means whenever you commit into the Git repository, this should be triggered automatically. And you also can pin your job into different Jenkins executors. So we have our own Jenkins cluster, auto-scaled, and it has different types of executors. For example, that's for Jenkins, that's for Ubuntu Prezi, because if for some reason you want to use something that's only available on Prezi, then you can tell Jenkins that this build can only be executed on Prezi nodes. And there is another thing, for example, deploy. You can specify that you can run my service by running that script, and you should open port 8000 because that will listen on that one. And so, yeah, like basically you can define every aspect of your service like this. And if you put this file into your project's root directory, then whenever you issue commands, like in the top right corner, you can see the some of the Igor commands. Igor just sees into this file and knows what to do. For example, Igor init is just something like git init, so initiate the project. Igor cook is, so if you are familiar with chef, you know that in the chef world, everything is named by some cooking stuff. So like, the command line tool for chef is called knife. All the recipes you want to run on the servers, like the list of statements you want to execute on a server, they are called recipes, and all sorts of stuff. So we named our config generation command cook, which means that based on the stuff that's written in your Igor YAML file, it will just generate a bunch of chef roles and chef recipes and cookbooks for your application, and then you can just simply copy that into the your chef repository, and that will be executed on the servers and apply the changes. And Igor sync, it's a command that you can run after setting up your project, and if you want to let Igor know that you changed something in this file, you can just sync it. But right now we are working on making it automatic. So basically it's a Git hook. If you commit your project and we examine your Igor YAML file and we see that something is changed, we automatically execute an Igor sync. But we are not sure yet if it's a good idea or not. Yeah, and there are some changes in the architecture we introduced lately. We are right now working on this Sergey project, which is basically the Sergey server side of Igor, because there are some things that are not a good idea to try executing concurrently. For example, if you are playing with the recipes, the configuration recipes, then if two developers are updating them at the same time, this means that Igor will update the same shape repository from two places concurrently, and that's not a good idea because it will lead to a lot of Git conflicts. So then we decided to move the parts from Igor that are very sensitive to concurrent execution into a server module, and then we can serialize all these statements that issued by our users and basically just execute them on the server, so it won't lead to conflicts. So this is how Igor and Sergey works, and the current state of the project is that, so these are our KPIs that we want to achieve. The speed was to create a backend service in 3 minutes. We failed that. So we can now create a service in like 50 minutes, which is still good enough, but we didn't reach our goal. Robustness, like at most one manual intervention when creating a service, that's done. And the penetration, like 80% of the new backend services use Igor, and the actual number is around 84. So we also reached that. So the things that Igor right now does for you, it creates all the test jobs and the dependencies between them, including if you want to archive artifacts, then you can do that from your Igor YAML file, or also you can build your project there, not just execute the test jobs. It also generates the build scripts for you, generates all the Amazon credentials, and integrates your project into the deployment infrastructure and generates all the config files for you. So after 5 months of development, and this is not a very fresh data because it was like 3 months ago, but after 5 months, altogether my team worked on 54 man days on this project, and already 13 projects are using Igor within the company. So within that 5 months, we created around 15 new backend services, and I think only 2 of them is not using Igor. So the time saved is around 20 man days, which results in a 37% return on investment. But we are not actively spending time on developing Igor, but our backend developers are still creating services with it. So this is just counting higher up and up. So the estimate is like maybe middle of next year will be like a total return, and from that on it will be a net win. So yeah, this is the story of Igor, how we built our continuous delivery pipeline integration tool. And that's why we think you shouldn't be afraid of building your own tools, because on the long run it will save you a lot of time. Thanks for your attention. Yeah.
Is Igor tied to a specific language or technology? Because when you generate build scripts and test scripts, they might be different between different languages you're using.
So basically we are just generating wrapper scripts for your own build script. So in the way Igor works, like it didn't really start with Igor, but it's what our best practices are. You should have a script called this in your application directory, and that should be able to build your whole shit when executed and stuff like this. So it's not tied to any language, because if you wrote that script and it's in your directory at a certain location, then you can just run it. So yeah, we are using Igor with Haskell, Scala, Java, Python, C++, just name it.
So you just have conventions for
Yes.
names and what the
Yes.
delivery artifacts are.
Yeah.
Okay.
Yep.
Is it open source?
Yeah, so I've been expecting this question. It's not open source because we think it's very closely tied to how our systems work. So from the beginning, we were keeping this in mind, that it will be a good tool if we manage to build it. So it would make sense to open source it. But like the longer we kept on thinking about it, the more clear it became that it's not useful for anybody else. There are some parts of it that can be, for example, the AWS credential creation, that's pretty useful for everyone. But other things like integrating it to your project into our deployment system, it only makes sense if we open source our deployment system, but we are not ready to do that right now. So yeah, it's not open source, but it wouldn't be too useful for anybody else. But if you want to try it, we are hiring.
The KPIs that you mentioned and also the return on invest calculation.
Yeah.
Who drove these things? Was it your manager, or was it you that you would actually, or was it, did you start with it, like to convince your boss that it's a good idea to build this? Or
I came up with some of these ideas, mostly these. So when I started working on this project, I was new at this company, and I came from an investment bank. And I had all these things in mind that like in a big enterprise environment, you have to have all these numbers, and it's an agile company, and everybody was just laughing at me that we don't care about these things. We don't even know what return on investment means. But yeah, like it turned out that they are very useful, especially the persona. Like having a persona is something that you can, like, basically she can decide all the debates within the team. So whenever we were debating, like, should we provide defaults, or should the tool ask for something when you are typing comments? And like having a persona always helped us deciding like what would be convenient for this 21-year-old girl just came out from university. She probably doesn't know what even an AWS security group is, so just use something before. So I think, yeah.
So when it was accepted, or like people liked the idea?
Yeah, people like it.
Because the return on invest is something that kind of, I really like it, but on the other hand, like the 30-something%.
Yeah, it's not so convincing.
It's not so much,
yeah.
But when I think of the other projects I did, like the return on invest was a lot lower, but still, like engineers tend to do this stuff, like
yes.
automate the hell, but nobody's asking for return on invest.
Yeah.
You do it for fun.
I think it will be.
There are also non-measurable returns. Like if the engineers aren't annoyed by going back and forth in whatever, they can actually probably produce their code faster anyway. So that's not measured, but it probably has even a bigger impact than the tool itself. I think.
That was measured. You wrote there like
it was the direct impact, right?
Or something like that.
Oh, yeah. I was talking about the fact that while they're writing their code because they're more focused, because they're not annoyed with that other thing, the actual time used to write the code is more efficient in itself.
Yeah.
In that way.
But actually, these numbers are like 4 months old, because first I did this presentation in February. Yeah, and so these data points are from February. Since that, I think at least 10 new projects were created with it. So if you do the math, it's above 50% now. So yeah, it's just counting up and up, because we don't spend time on developing Igor. So like the ratios are better and better.
you're doing canary deployment for gradually deploying new services.
Yes.
Right? So how do you test these few instances, few new instances? Like, is it automatic or it's manual?
It's a part of the responsibility of the service owner. So I don't know how to measure if your service is operating right or not. But if you have a script called this in your application directory, and if I find it, then I will execute it after deploying your project, and it just returns a number between 0 and 1. And if it's close to 0, then probably shit has hit the fan. But if it's close to 1, then probably your service is operating right. For example, you can compute the ratio of 200 versus 5 and 400 HTML response codes. And if like you have a very, very large amount of 4 and 500s, then probably something is not okay. But I don't care how you measure your own service. Like, for me as a framework provider, I just give you the room for having that script, and that script should know. Like, you should know how to test your service. Okay.
Yeah, so the pizza is going to take a little longer, so I think we will change the schedule, and let's have a 5-minute break so everybody can grab a fresh beer.